Hi students, and welcome to your next lesson, Order of Operations. This is lessons 1.10 through 1.12. This is the lesson that we've been waiting for. We've gone through this entire unit, and this last video is going to tie together everything we've learned in chapter 1. So let's take a look at our scale. Our goal is to understand how the order of operations, I already started underlining. The order of operations algorithm helps us solve numerical expressions accurately. Now, we've told you many times how important it is to understand the vocabulary that is used in math. So let's break this down. Order of operations algorithm simply means the order or the sequence of operations. There's a certain way that we have to solve expressions, and we have to do the operations, or as you can see here, multiplication, division, addition, and subtraction. We have to solve them in a particular order. And when we say algorithm, it simply means a way, and it can also mean a rule. So we're looking at the rules for the order that we do multiplication, division, addition, and subtraction if they're all in the same problem. And then numerical, you recognize this part. It reminds you of the word number, and that's exactly what it means. We're trying to solve expressions that have numbers. We're not talking about poetry expressions. We're talking about expressions that contain numbers. And to make sure you remember, 4 times 5 is an expression because it doesn't have the equal sign and an answer or the product. But 4 times 5 equals 20. Now we have this portion, the equal sign and the product. That is called an equation. And we don't want to get the two of them mixed up, because if someone asks you to write an expression, you do not want to write an equation instead. The vocabulary is extremely important. And then finally, accurately means correctly, the right way. So let's tie that all together. We want to use the order of operations rule to help us solve expressions the right way or correctly. And that's exactly what it means. And so our goal is to be right here to solve problems containing multiple operations, which means hopefully we can solve problems that have a multiplication, division, addition, and subtraction, all in the same expression. Now let's find out how we do that. You might have heard this before, and I'm sure you have. Please excuse my dear Aunt Sally. Well, guess what? That's the order of operations. But the please excuse my dear Aunt Sally is called a mnemonic. And mnemonics are phrases or sayings that we use to help us remember something. And this one's great. I used this one when I was in school too. It means that first we look for parentheses or brackets. Second, we look for exponents. Third, we look for multiplication or division, whichever one comes first from left to right. Then we look for addition and subtraction, and we solve those, but whichever one comes first from left to right. Let's actually put this into practice, because you'll understand better what I mean if we solve a problem. So here's an expression, boy oh boy, and I wonder how we're going to solve it. Well, first we need to look for the innermost bracket or parentheses. Where is it? I see it. Right here, 4 minus 2. So the best thing to do is to do this in steps. And when we're solving in steps, we rewrite every portion of the expression. What is 4 minus 2? Correct. 4 minus 2 is 2. Plus 49 divided by 7. Now what should we do? Do we have parentheses anymore? Yes, we do. So we need to solve this expression. But there are 3 operations within the parentheses. How do we decide which one to do first? We follow the order of operations. So inside, do we have parentheses inside the parentheses? No. Do we have any exponents? No. Do we have multiplication or division? Yes, we have division. So we're going to solve this portion next. 25 divided by 5 times open parentheses 2 plus, what is 49 divided by 7? 7. Now we're going to start over. Do we have any parentheses? Yes. We're going to solve what's inside the parentheses first, because we're always looking for the innermost parenthesis or bracket, the one that's snuggled inside the coziest. Let's rewrite our expression. 25 divided by 5. And notice how I keep rewriting the parts that we have not solved yet. Okay. Do we have any more parentheses? No. Exponents? No. Multiplication or division? Yes. And we have both of them. Now we have to solve from left to right. So which one comes first from left to right? Correct. 25 divided by 5. So step 4 is to solve the expression 25 divided by 5. What is 25 divided by 5? 5. And 5 times 9 is 45. Now I do want to caution you, which means I want to warn you that if you have to use any other strategies, which is okay, to solve the expressions, use your other strategies over on the side. For example, if I said, okay, the easiest way for me to solve 5 times 9 is to make 9 groups and put 5 in each group, and then come back and skip count by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45. If it's easier for me to do that, make sure, boys and girls, that you keep your work for solving each expression over on the side, and that you keep your steps for the order of operation all together. That way you won't get confused. So let's keep going. Here we have 3 expressions that I'd like for you to solve. I think it would be best if you paused the video and gave this a try for yourself, and then come back and see if you did it correctly. You can pause the video now. Okay, notice that each one of the answers is completely different. That's why we have to use the order of operations rule. And we call it an algorithm. These parentheses, and the brackets, and the parentheses here, they change everything. The answer to each one of these, even though we're using the same numbers and the exact same operations, the answers are all completely different. And you'll notice that I didn't have enough room to solve and to follow the steps in this space, so I moved my work over here. That's a responsible thing to do, because as you solve these equations or these expressions, you're going to need to leave yourself enough room to check your work and for your steps to be clear for anyone who wants to help you to see. Let's keep going. Here we have another problem. You notice that there is not a lot of support, so we're going to have to help ourselves. So we remember, please excuse my dear Aunt Sally. Do we have any parentheses? Yes. So we need to solve what's inside first. 2 times 10 to the third power. Do we have exponents? Yes. 2 times 1,000 is 2,000. Pause the video and try the next one on your own. Okay, here we have the answers. Use what you see to check your work, and then we'll go on to the next problem. Sometimes when we're solving a problem, we have to create the expression ourselves, and then we have to solve it. Here's an example of one equation that is used to solve a problem. Now, don't freak out because you see this super long equation. All we've done is taken all the steps that you would use because you're an amazing mathematician. We've taken all the steps you would use to solve this problem, and we've mashed them or put them all into one expression. And actually, it's one equation because there's an equal sign, and the A stands for the answer. Let's break this down so that you're not confused. Mr. Loveland's class parents decided to make Halloween goodie bags for his 24 students. They want the bags to each have the same number of, or the same amount of goodies, and the budget is $150. So if we were solving this, we would first figure out how much each item is, and that is here. So if we have Skittles and there are 2 packs in each bag and they're each 50 cents, we know that that's going to equal $1. So we have to do all of that addition first, but before we do the addition, we've got to multiply the Skittles and eraser. So that's the part we're doing first. And you can see that here. Then we'd have to multiply by the 24 students, which is here. Then we'd have to say, okay, the total cost of a whole bag is going to be $5. So we would solve 24 times 5. That's $120 to make bags for Mr. Loveland's 24 students. And then we would subtract the $120 from the $150, and it means that we have $30 left over for Mr. Loveland's vampire cape. Take a moment, look at this for yourself, and see if you understand. Here's another example that we could do together. Mr. Loveland's class decided to make Halloween goodie bags for his 24 students. They wanted each bag to have the same goodies. One parent donated $100, another donated $150, and here's how we solved the problem. Take a look at that. Now, a great strategy to use would be to solve the problem on your own and then come back and create an equation that has each one of the steps. Most of you would probably say, okay, well, let me add this up first. And then you would say, okay, next I need to do this part. So then you would put it here. And then you'd say, okay, but I need to multiply this. So you'd write the number 24. Then just come back and put it inside of the brackets. And that'll make it easier for you. I'll do an example down here. First, I would add up all of this information. 1 plus 1 plus, and I put all that together, and I know I need to multiply it by whatever the number is by 24. I need to subtract this whole thing by 100 plus 150. Do you see how I'm working backwards? And then that's how you can do it for yourself. And I would change these to brackets because I already have parentheses. So sometimes working backwards is easier. I hope this helped you. Or I hope it helped you. Now, try to solve this problem and we'll come back and give you the answer. Hopefully, this is the answer that you got. There's no money left over for Mr. Loveland's vampire cape. And finally, look at the scale and see if there's anything that you need help with. Write your questions down and your teacher will assist you tomorrow.